So let's define the Fibonacci sequence. The Fibonacci sequence is a set of integers, the Fibonacci numbers, that starts with a 0, followed by a 1, then by another 1, and then by a series of steadily increasing numbers. The sequence follows the rule that each number is equal to the sum of the preceding two numbers. The Fibonacci sequence begins with the following 14 integers: 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, 233. Each number, starting with the third, adheres to the prescribed formula. For example, the seventh number, 8, is preceded by 3 and 5, which add up to 8. The sequence can theoretically continue to infinity, using the same formula for each new number. Some resources show the Fibonacci sequence starting with a 1 instead of a 0, but this is fairly uncommon. So this is an example on how you manually solve the Fibonacci number.
Okay, so we have here one of our example. So find the 14th term in the Fibonacci sequence. Okay, so we will try to use our formula for this problem. So we have the formula Fn is equal to 1 over square root of 5. We have 1 plus square root of 5 over 2 raised to the power of n. Okay, so our n here is the number of terms. So we could get our number of terms by get it from the problem, which is we say 14 terms. So the number of terms of our sequence is 14. Okay, so that is what we mean as our number of terms, the n. Okay, so we will try to solve this one. So we have Fn is equal to 1 over square root of 5. So 1 plus square root of 5 over 2 raised to the power of 14. So our f of n, so we'll use our calculator here. Okay, so we have, so we can just directly input the problem in our calculator. So you have 1 over square root of 5 plus times. Okay, so we have 1 plus square root of 5 over 2 raised to the power of 14 . Okay, and we have, okay, so this formula is just an approximation, so we could round to the next whole number, which is 377. So 300, okay, 377, and this one now is our 14th term. So we could write our f here as f14. We should delete this one here. Okay.
So we managed to make a program that enters a number and it will find the Fibonacci number of it. Enter a positive integer, 100 Fibonacci series 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89. In this program, we have used a while to print all the Fibonacci numbers up to n. If it is not part of the Fibonacci sequence, we print the sequence up to that number that is closest to or lesser than, supposing 100.